In this set of notes, I'm going to discuss an analogy known as the Electron Hotel. What this analogy is it's a way of understanding how electrons fill up the different orbitals and sublevels of an atom. But the analogy, I don't know, it sticks with a lot of people and it helps people to understand, and so I'll go through and explain about this hotel, and then when we move on to talking about the atom and the electrons and the way that the atom is filled up, hopefully you can remember some of these ideas and make those connections this way. So here's the story. There are these three fellows who come together and they decide that they're going to build a hotel. Their names are Mr. Pauli, Mr. Aufbau, and Mr. Hund. They're sort of eccentric old fellows and they've got these strange ideas about how they want to build this hotel. So the first guy, Mr. Pauli, this is what he says. He says, all of the rooms have to have bunk beds. So this guy, he really loves bunk beds. I don't know if he spent a lot of time at summer camp or what it is about him, but he loves the bunk beds. Aufbau, he's all about energy efficiency, so he says, okay, I'll give you your bunk beds, but when we fill the hotel, it has to fill from the bottom floors to the top floors because we don't want people riding up the elevator if they don't need to, so bottom floors first. Mr. Hund, sort of along the same lines as Mr. Pauli, is concerned about these bunk beds, but he says, if we're going to use bunk beds, we have to acknowledge the fact that the top bunk is way, way better than the bottom bunk. So if you've got a room and you're filling the room and there are any top bunks left in that room, you got to fill the top bunk first. All right, and then the bottom bunk. So these three sort of crazy guys, this is their idea, and they go through and they build a hotel. So what I'm going to talk about now is kind of the construction of the hotel, a little bit of the story here. So they're going to be constructing it sort of from the bottom up. So it's got 7 floors. They go and they start and they build it, and it has, on the first floor, it has a suite. All right, the suite just has 1 bunk bed in it, and nice little room there. Most of the floor there is made up of the lobby, but they got this one suite. Seems pretty good, so they build another suite on the second floor, and things are getting pretty popular, so they build another room, which they call a party room. This one has 3 bunk beds in it. All right, so 6 people could sleep there all together. Then on the third floor, they build another suite, and they build another party room. All right, and then it's getting so popular that people are trying to come to this hotel, and they can't get it built fast enough, so they create this room. They just throw 5 bunk beds in, and they call it the dump room. All right, so it's got 5 bunk beds in there. 10 people will sleep. It's sort of like if any of you ever have slept in a hostel, or you know what a hostel is like. Basically, a hostel is just like this cheap place where you'll just rent the bed, and you'll stay in there, and there'll be maybe some other strangers you don't know in the room, and something like that. So in this dump room, there are 5 bunk beds. 10 people sleep in there. On the 4th floor, they build another suite, another party room, another dump room, and then this next room, what I think of is I have a pretty big family, and sometimes we like to get together and all be in one place, and so they built this room called the family room, which has 7 bunk beds in it, meaning 14 people could sleep in this room. And so this room would be really good, if you had a large extended family, wanted to do a family reunion or something like that, your family could stay in here all together. So I know it's pretty weird so far. These are weird sort of fellows, weird rooms, but we got the suite, which has 1 bunk bed. All right, we got the party room, which has 2 bunk beds. We got the dump room, which has 5 bunk beds. All right, sorry, party room has 3. I think I maybe just misspoke. And then the family room has 4 bunk beds. So now we got to talk about, as the people arrive, where they would go. According to the rules, we had you have to fill the bottom floor first. All right. And I got to fill the top bunk first. So the first person here, they go in the first floor suite, top bunk. And then we have to fill the bottom floor, so bottom bunk. Then the next person comes in. They go to the second floor suite, top bunk, and then bottom bunk. And then they start filling this party room. And remember, the rule is that you got to fill the top bunks first. So here's how it goes. First person arrives, top bunk, top bunk, top bunk. And then we fill bottom, bottom, bottom. All right. Next person arrives, top bunk, bottom bunk. All right. Party room, so top, 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 bottom, bottom, bottom. Okay, now this weird thing happens. So what happens is, along this story, like an old rich couple arrives at this hotel and they ask for a room. And according to the rules, they say, all right, we got a room for you. You're going to stay in our third floor dump room. But the idea here is this old couple sort of doesn't like the idea of this dump room. They're wealthy. They don't want to be in a room with all these other people. It's not a very good room, and so they ask if they could please be moved to another room. And so after paying an extremely generous amount, the owners of the hotel decide, all right, this one time we'll make an exception. And this old couple goes up to the fourth floor suite. And then after that, we fill the dump room. All right, top, bottom, bottom. All right, so that's how that goes. All right, and then we would fill the 4P after that, top, bottom. All right. Okay, so here's the actual connection. The electrons, this is all about how they fill the orbitals within an atom. The floors of the hotel represent something that will be known as energy levels. The rooms in the hotel are what we call sublevels. All right, and then we've got these 4 different types. S, P, D, and F you're going to hopefully become familiar with. It stands for sharp, principal, diffuse, and fundamental, although I don't think the names of the different sublevels help you really understand what they are, so just remember S, P, D, and F. The beds are each an orbital, and if you don't know what an orbital is, make sure that you watch the PowerPoint presentation on our modern idea of the atom, because that one talks about all these different things in terms of sublevels and things like that and what all of that means. All right, so in each orbital, 2 electrons fit. So 1 bunk bed, 2 people. That's kind of how this works. So now I'm going to go ahead and show you how this can be understood along with the periodic table. And so the first thing we do is we actually take helium and we move it over by hydrogen. This just makes a little bit more sense in the way that we organize things and the way that we talk about them. This is because we have the 7 rows. All right, the 7 rows are like the 7 different energy levels or the 7 floors of the hotel. All right. If you look at the atomic numbers and you read across, it goes 1, 2, and then you drop down 3, 4, 5, 6, 7, 8, 9, 10. So just like you'd read a book, left to right, top to bottom, that's how we're going to go through these. There's some different parts of the periodic table. So there's this S block. All right, this is for the S sublevel, and there's P, and then D is here, and then F. All right, so these are these different sections of the periodic table. Go ahead and if you're taking the notes along with this video, pause it and draw these in. All right, and so you'll notice that these go along with the sublevels, the S sublevel, the D sublevel, the P sublevel, or the F sublevel, or the different types of room, the suite, the party room, the dump room, and the family room. Okay, similarly, remember that there are those bunk beds or those orbitals. So inside an S orbital, inside an S sublevel, we have 1 orbital. In the P sublevel, we have 3 orbitals. In the D sublevel, we have 5 orbitals. And then in the F sublevel, we have 7 orbitals. So those are like all the bunk beds that we had in the rooms. Okay. Here's something weird, though. Normally, when we're going through this, we'll read through first row S block, second row S block, third row S block, things like that. But this weird thing happens with the D's and the F's. So the D's and the F's are all off from what row they're in. You'll see that we go here from 4S across, and then we enter into 3D. And then over here on the other side, we would call this 4P. Then we go also like 5S, we go through 5S, and then we go into what we call 4D, and then we jump out on the other side, and this is 5th row P block. All right, so the D's are all down 1 lower than what row they're in. So as you go through 4S, then 3D, then 4P. So just an adjustment to make in terms of the numbering there. And then the F's, I don't know if you're familiar with this, but the periodic table that we look at, this F block down here on the bottom, this is actually inserted right here in the periodic table. You can see the letters go 57, and then it jumps down here to 58, 59, 60, all the way through 71, and then 72 comes here. So this F block fits right in here. And so we go 55, 56, 57. All right, we're in the 6th row S, and then we're in 5D, and then we jump down here to 4F, and we go all the way through here. and then we jump back up here to number 72, and we go across and finish out our 5D, and then we're in 6P after that. We actually don't really do much down here with the F block, so if that's pretty confusing to you, probably don't have to worry about it too much for now. We mostly stay up here in the S, P, and D blocks. Okay, so I'm going to explain to you how we create a diagram for one of these, and this is like a really hard, really long one, just so that you can see how the entire process works. And so what we're going to do is we've got to find radium here on the periodic table because we're going to create an orbital diagram for radium, which is Ra. It's down here, it's number 88. And so what we do is we have to think of all the different parts of this periodic table we would go through before we get to radium. And this is how it works, alright? So we first go through 1s, alright? Then there's nothing across here on the periodic table, so there's no such thing as a 1p. So we go through 1s, and then we jump down here, and then we go through the second row S block, and then we jump across and go through second row P block. Alright, then we jump back down, and we go through third row S block, and then we go across here, third row P block. Alright, notice the number of lines is different for the S's and the P's. Remember, the S's have just one orbital in them, but the P's have 3 different orbitals, or it's like the bunk beds in the rooms, right? The suites had 1 bunk bed, the party rooms had 3. So there was more space for electrons to fill within the P. Also, notice there are only 2 elements per row in the S block. There are 6 elements per row in the P block, so that goes along with it as well. So if we go through third row P block, we jump down here, we go through fourth row S block. Alright, and this is where the D's are kind of funny. D's drop down by 1, so we go through here, but instead of being 4D, it's 3D, because the D's are 1 lower than they should be. Alright, and we go all the way through 3D, and then we jump over here, and then we're going through fourth row P block. Alright, and then we jump down and we go through 5th row S block. Alright, then we're going to go through what we call 4D. Alright, because again the D's are down 1 lower than they should be given the row that they're in. And then we jump out here, and this is 5P, 5th row P block. And then we jump down 6S, alright, 6th row S block. And now here we start to go through this 5D, but then we jump down here and we go through this entire thing 4F. Alright, so we go through this entire 4F, and then we jump back up here and we go through the rest of 5D. Alright, and then we go through the rest of this row, that is row 6P, 6th row P block. And then we jump down here and we go through the 7th row S block. Alright, and that's actually where we end, because radium is in the 7th row S block. Alright, so that's all the orbitals that we have, and now we have to think about how we would fill them. The way you fill them, again, you're going to fill from the bottom to the top, from the start to the finish, I mean, and then as you go, if you're in a sublevel, you need to fill them in order of all up arrows first. By the way, the arrows mean, and I'll talk about this more in a different PowerPoint, where again I'm talking about the modern model of the atom, but the arrows represent the way that the electrons are spinning within an orbital. So people ask sometimes what the whole significance of the arrow is. Within any one orbital, we can have an electron spinning one electron spins one way and the other one spins another way, and they create an electromagnetic field as they spin, and so they kind of balance each other out if you have one up and the other one is spinning down. And so again, it has to do with the direction that electrons are spinning. So we fill that in. First row S block, top, bottom. Alright, second row S block, top, bottom. Now we've got second row P block, and so this is one of those, like, it was a party room in the Electron Hotel analogy. Generally speaking, you can just think of it as an S sublevel, or sorry, P sublevel. There are 3 spots for electrons to fill here, so we're going to fill it top, top, top. Alright, and then we'll fill the bottoms, bottom, bottom, bottom. Then S, we go top, bottom. Then P, we go top, top, top. Bottom, bottom, bottom. 4S, we go top, bottom. For the 3D, we go top, 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 top. And then bottom, 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 bottom. Alright, and we'd actually fill up all the rest of these that same way. All right, so going through doing an easier example for carbon, you might choose to pause the video at this point and try and see if you can do carbon yourself. Otherwise, I'm going to go through it right now. So going through carbon, this is a much easier example. So if that last one was a little too much for you, this is more like what you'll be expected to do in class. So to get to carbon, first you should figure out where carbon is. It's right here. It's atomic number 6. All right, it's located in the second row P block. So 2p is the last thing that we're going to get to. So we go through first row S block, and then again there's nothing across here, so we jump down second row S block. All right, and then we move over here to second row P block. All right, and then we're going to fill this up. So second row P block, we go top bottom. All right, and then top bottom, and then you think, all right, we got second row P block. The carbon is the second atom in. We've got boron, and then we've got carbon in the second row P block. So we've got 2 electrons left. The other way you can think of this is carbon is atomic number 6. Assuming that you've got a neutral form of carbon, there should be 6 protons and 6 electrons. So we've already got 4 electrons in there, all right, in the 1s and the 2s orbitals. So we only have 2 electrons left. And then similarly, I said, if you're thinking about this 2p sublevel, we've got 1, 2 elements in, so there's just 2 left. All right, so we go top, and the second one is top. So this is what's called the orbital filling diagram for this. This is the correct answer for carbon. We're going to do the same thing for oxygen here. So it's in the same 2p. So we go through 1s, then we go through 2s, and then we're in 2p. Top, bottom, top, bottom, top, top, top. All right, and then we have one more than that, so we go bottom. All right, because there are 4 electrons in on that second row P sublevel. So this is what it would look like for oxygen. After that, there's this thing that it asks for called the electron configuration. What you do for the electron configuration is you just go through, you write the sublevel and how many electrons there are in the sublevel. So for instance, for this oxygen, you'd say 1s, 2, 2s, 2, 2p, 4. So you say the sublevel and then how many electrons there are in there. 1s2, 2s2, and then 2p4 for the electron configuration. If you'd like some clarification on how to do that, come in and ask. It's pretty easy, and I'll just show you. To go through the other example we had here, for carbon would be 1s2, 2s2, 2p2, because there's only 2 electrons there in that 2p sublevel. So again, if you would like me to show you, I can show you. Other than that, you could go ahead and Google electron configuration if you want to see it that way. Either way, I think you should be able to figure it out. And let me know if you have any questions on any of these things.